To use NoizCalc for far-field simulation, several preconditions have to be met. You need a PC running Windows 7 or higher, Google Earth version 6.2.2, ArrayCalc 8.8 or higher, and an internet connection. While multiple terrain data sources can be used, we will show it with Google Earth in this example. To prepare an ArrayCalc project for NoizCalc, the NoizCalc reference point has to be enabled. This setting can be found on the NoizCalc tab within the ArrayCalc options. The reference point is needed to compare the SPL within the audience area, typically at front of house, with the emission level at a given off-site position. To move the reference point, use the coordinate fields below the 3D plot. Make sure that all acoustic settings of your project are as intended for the show. Then save the ArrayCalc project and open NoizCalc. On the Project Settings tab, select the calculation standard first. Also, choose a coordinate system for Northern or Southern Hemisphere and the reference system. This is important because it affects all following parameters of the workflow. To obtain project information from an ArrayCalc file, please press here. Change to the Editor tab. NoizCalc will prompt you to set the area of interest. This is easily done within Google Earth. To obtain proper terrain data, the following function must be activated. Go to Tools, Options, and check Show Terrain. Then navigate to the desired area and make sure that the eye view is looking straight down. Now switch back to NoizCalc. The respective mapping and elevation data will be imported automatically. Now it's time to define acoustically relevant terrain features. As a hint, features which are close to the PA or to emission points of interest are the most important ones to enter. Select Ground Effects to define surface properties. To create a surface, simply click along the outlines of a patch of ground. Double-click to close the surface. After that, set the ground factor. 0 means hard ground, such as a road. 1 means soft ground, such as a patch of grass. Mitigation areas such as forests or brushery can also be defined. The creation process works very much the same. Select the tool, then click on the bitmap to define the area and close the element. Then enter an average height for the vegetation. Create walls or buildings to include reflective or screening effects into the simulation. These objects are inserted and adjusted in the same way. For detailed information about these parameters, please have a look at the help function. Having created all surrounding elements, set a desired calculation area. Now it's time to import the sound source. NoizCalc calls it the stage, but what it really is your ArrayCalc project file. Use the File dialog box to select it from your hard drive. Click into the mapping to place the stage. The insertion point relates to the origin of the ArrayCalc coordinate system. Use the control to adjust the orientation. After that, an excitation signal spectrum representing the expected program must be chosen. Several spectra are available, from generated standard noise signals to typical responses of rock, pop, speech, or even German traditional brass music. Now enter the expected level at the green reference point here. In this example, we'll use 90 dB. Prior to simulation, environmental conditions have to be specified. Now press Run to start the calculation. The result will be shown in the graphic plot. The legends can be modified by clicking on them. The result can also be exported as a bitmap for further use.